Okay, let's look at a couple more examples of some of the properties that we've discussed. All right, we've got a quotient of powers here. So I can look at since I know these powers, 4 and 7, the exponents are only attached, if you will, to the x's, then I know I can take the 5 over 10 and reduce that on its own. That's 1/2. 5 over 10 is equal to 1/2. And the exponents, when they're in a quotient or a fraction, can be subtracted if the bases are the same. So I can go off to the side here and say, well, what's x to the 4 minus 7? That's x to the negative third power. So that would be x to the negative third. Now because that's negative, I'm using 1/2 as the coefficient here, but I have a fraction in this problem now, and since I have a negative exponent, I can take this power and write it in the denominator. So that would be 1 over 2 x cubed. Okay, let's look at this next one. We've got the product of two powers. I can take, I'm using the shortcuts now. I can multiply the two coefficients together, and I can add the exponents. Y to the negative second and y to the third. If you need to go off to the side and do this, negative 2 plus 3 is 1. So this is really y to the first. So I get negative 12 y as my final answer here. Down here, again, I've got a quotient or a fraction. I notice that the 2 is not a part of the 6. The 6 is not attached to this exponent. The 2 is not attached to this. So I'm going to take these two coefficients and I'm going to divide them. 6 over 2 is equal to 3. And then I can take these powers, which are 2 and negative 2, and subtract them because they're in a fraction. So we have x squared minus negative 2, which is a positive 4 for this, x to the positive 4, which I would then attach back to that coefficient that I had from the beginning. Let's look at this last example down here. Okay, I've got a quotient of powers raised to the negative third power. Bunch of different ways that I can go with this one. Here's the approach that I'm going to take. I can, quote unquote, distribute the negative 3 to the numerator and the denominator. Now, the numerator and the denominator are both products. So going back to a question that we had done previously, I can distribute this not only to the top and the bottom, but within the top, I can bring that in as an exponent of 2, and I can bring that in as an exponent of this power that's already there. The same thing will happen down here with the 7 and with the y. So what I'm going to do is I'm going to rewrite this entire quotient after I've distributed this negative 3. That's 2 to the negative third. This will be x to the negative sixth, right? Because powers of powers or exponents of exponents get multiplied together. So this is x to the negative sixth power. On the bottom, I'm going to have 7 to the negative third, and then y to the negative ninth. And what you notice is that every single power here has a negative exponent. And negative exponents, we change their position relative to where they start. So everything that has a negative exponent on the bottom is going to move up. Everything that has a negative exponent on the top is going to move down. So I end up with 7 cubed. 7 cubed is 343. If you know that, great. Otherwise, type it into your calculator. And then I have y to the positive ninth when I move it up. 2 to the negative third is 8. I'm going to move that down. And then x to the negative sixth, again, that's moving down. Everything has a negative exponent, so I have to change its position.